Okay, so here's the next page, 256. If you're fortunate enough to have a booklet, a work booklet that had numbers, but this page is wrong. It's out of order. It should not be here. So if you don't have this page next, don't worry about it. And it actually is page 249.5. So it goes in between 249 and 250, and I've uploaded that as a PDF, so it's attached to this post and it's fully filled out, but I've also done it with your classes. So we're going to leave that, and we're actually going to go on to the last two examples for geometric series. Okay, so this is example 3 and example 4 for geometric series. Example 3, in an amphitheater, seats are arranged 50 in semicircular rows. Okay, so there's 50 semicircular rows facing a dome stage. So we've got something that looks like this. Wee, 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 wee. All facing a little stage up here. And this is where Mariah Carey and Justin Bieber sing duets. Okay, so they're all watching that. And there's 50 of them. Okay, there's 50 rows. The first row contains 23 seats. The next row contains 4 more seats. The next row has 4 more seats. The next row has 4 more seats. How many seats are there in the amphitheater? So the first row is going to be 23 seats. And then the next row is going to be 4 more seats, so 27. And then the next row would be 31. And then the next row would be 34. And we see how this continues, right? And it's going to go all the way up to 50 of these terms. So I guess by looking at this, we can tell what A is. A is your first term, and we can certainly tell what D is. D is 4. And T sub n, my nth term in general, we could set up a formula for. So T sub n for any term is going to be A plus n minus 1 D. That's in general. We just know that. And so T sub n would be 23 plus n minus 1, and in this case it's 4. So if I wanted to, you could take the 4 in and I could expand that, and I'd get 4n, and I'd get negative 4. So 23 minus 4, it's going to be 19 plus 4n is my general term. So we know that there's 50 rows. So after 50 rows, T sub 50, that would be 50 terms in this, right? So the first row, the second row, the third row, the fourth row. So up to the 50th row would be 19 plus 4 times 50. 4 times 50 should be 200, plus 19 should be 219. So 219 is my last row out here, 50 rows out. So again, what I've got now is I've got a sequence that goes 23, 27, 31, dot, 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 all the way up to 219. That's my sequence. If I want the sum of that series, the series is going to be 23 plus 27 plus 31 plus dot, 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 plus 219. So the sum of the first 50, okay, the first 50 terms in this series is going to be given by one of the two formulas that we talked about earlier. So which formula would I like to use? Well, I think I would like to use this formula, where it's n over 2, and it's a plus t sub n. Because if I'm after the first 50 terms, I know that n is 50, I know my first term is 23, and I know my last term is 219. So we're using the Gauss idea here, where he lined them all up, he added them all, and when you add them all, you get 219 plus 23 in each of the terms, which is 242, and he's going to have 50 terms in total, but that gives him twice the number that he wants, so he needs to divide by 2, so he's going to get 25 times 242, and we are going to have an answer, an answer of 6,050 seats in total. So there you go. That was how I chose to do it. I'm sure that you maybe could have gone around and done other things. You could have used another formula here that had, instead of t sub n, it might have had n over 2, 2a plus n minus 1 d, and you could have used that formula as well. But since I went ahead and found t sub 50, it was easier for me to just use that value in there. Okay, so that's example 3, and I'll be right back with example 4.